Good morning, friends. Welcome once again to our class of physics today. Today, we are going to start with a very important concept of physics, which is electric potential, which is electric potential. Now, potential and potential difference we have already done in our previous classes, so we will continue. Now, before moving to the electric potential and the concept of potential, let us consider that suppose we have a Cartesian format where we are having the origin O. Now suppose at this origin we place a positive charge Q. Now one thing is very clear, that due to this charge Q, an electric field will be generated around this charge uniformly in all the direction, and which can be represented like this. This is the nature, or you can say this is the situation of the electric field that is spreading out in all the directions from the charge Q. Now this charge Q will produce what is called an electric field, which is E, and this electric field will exert a force, and due to that force, suppose we have a charge at A, due to this force, this charge or this body will be shifted towards B. And in order to do so, there will be a small work done by this electric force. This electric force, or you can say this electric field, will perform certain work in order to move a charge from A to B. And how much work is done by this field or the force, that is what we have to calculate in this article. Now, for doing that, let us take a point, and let us take a point P on AB such that the force, which is E, displaces the charge at P to a very small displacement, which is, let us say, dl. मान लीजिए जैसे ही हमने इस पॉइंट P पर एक यूनिट पॉजिटिव चार्ज रखा, तो ड्यू टू दिस इलेक्ट्रिक फोर्स, दिस चार्ज will be allowed to move towards B, and it will reach a point Q by covering a small displacement dl, and obviously it will perform some work. So the amount of work done in moving the particle or the charge from P to Q will be given by, you know what is work done, that is the force multiplied by the displacement, force multiplied by the displacement. Is it clear? Force is the electric field, that is E, and the displacement is dl. We are talking about the work done in moving the particle or the charge from P to Q. Now, in order to find the work done by the same force in moving the charge from A to B, what we have to do? We have to do the integration of the work done when it is moved from P to Q within the limits from A to B. तो पूरा वर्क डन निकालने के लिए हम क्या करेंगे, इस वर्क को इंटीग्रेट कर देंगे विद इन द लिमिट फ्रॉम ए टू बी. सो दिस इज द अमाउंट ऑफ वर्क डन इन मूविंग ए चार्ज फ्रॉम ए टू बी when it is placed inside an electric field. Any doubt? So this particular term, which is this integration of E dot dl, this is called the line integral. This is called the line integral of what is electric field. This is the line integral of electric field. It means what is the work done? Work done by a force in moving a charge from one place to another place is the line integral of the electric field. It is the line integral of the electric field. Anybody is having any doubt? Okay. Let us continue further. Now we have to find what is the value of E. What is the value of E? Now you can easily remember from your previous lecture that the force between the two charges will be equal to 1 over 4 pi epsilon naught Q by R square into unit vector R into dl cos of theta. If theta is the angle here, if this is the electric field and this is let us say the direction of dl displacement, this is electric field and this is the direction of displacement. So what is this? This is theta, the angle between the direction of the force and the displacement. Now, in order to find the value of dl, let us draw a perpendicular here. Let us draw a perpendicular here. Any doubt? Now, you can understand if this is the perpendicular and this is the angle, then what will be this? Obviously, this will be my base. Base is the side which contains both of the angles. So if this is perpendicular and this is theta, this is base. And what is the side opposite to the right angle? The side opposite to the right angle is your hypotenuse. That is your hypotenuse. So if suppose this is N and this is P and obviously this is Q, so what will be your Pn by PQ? Base by hypotenuse. Base by hypotenuse is your cos of theta. So what will be my Pn? Pn will be equal to PQ cos of theta. And what is Pn? Pn, it is, let us say, small dr, the displacement along the position vector. This is my r. So when it goes further, तो यहाँ से हमारा perpendicular आया है. So this is my small displacement dr in the direction of r. And what is PQ? PQ you all know. It is a small displacement dl cos of theta. What does it mean? It means where we are having dl cos theta, its value will be equal to dr. तो जहाँ dl cos theta है वहाँ पे क्या लिखेंगे dr. ये कंसेप्ट आपको क्लियर है? ओके, सो व्हाट आई विल डू, आई विल सिंपली चेंज माय इक्वेशन टू E इज इक्वल टू सॉरी दिस इज वर्क डन. वर्क डन बिकॉज डीएल आ गया ना. वर्क डन इज इक्वल टू 1 over 4 pi epsilon naught into q by r square. Unit vector, this is unit vector, the magnitude is 1, so that is out, and in place of dl cos theta I have to write dr. Anything to be asked? Good. Now in order to find the total work done, what I will do, I will integrate this entire term within the limits from a to b. Within the limits from a to b. Now I have to see what is the limit of a. Limit of a means the position vector of a. This is a. This is origin. So position vector is ra. This is origin. This is b. So position vector is rb. Any doubt? So that means work done will be equal to, now you will appreciate that these terms are constant. That means 1 over 4 pi epsilon naught into q. It is constant. So I am left with 1 over r square dr integrate within the limit from ra to rb. From ra to rb. Any doubt, my dear friends? So when we do the integration, basic concept everybody knows. What I will get? I will get wd is equal to 1 over 4 pi epsilon naught into q r raised to the power minus 2 plus 1 over minus 2 plus 1, and when you apply the limit from ra to rb, and when I solve this I get minus 1 over 4 pi epsilon naught q into r 1 over upper limit minus lower limit. Upper limit minus lower limit. Now when we take this minus inside, or you can say when we multiply the entire term with minus, what we got? The work done in moving the charge from A to B. Listen carefully. The work done in moving the charge from A to B will be equal to 1 over 4 pi epsilon naught q into 1 over RA minus RB. क्योंकि ये माइनस था, अंदर का साइन चेंज हो गया. तो अब जो बात समझनी है बड़े ध्यान से वो ये है कि जब हम बात कर रहे हैं वर्क डन इन मूविंग द पार्टिकल ए से बी की तरफ, तो आर ए माइनस आर बी, दिस इज द वर्क डन. और अगर सपोज वी हैव टू फाइंड आउट work done from B to A, तो क्या होगा? शाबाश, तो क्या होगा? हाँ, ये हुई ना बात. That means RB minus RA. Shabash. So this is what is going to happen if you have to find the work done in moving a charged particle from position 1 to position 2 to 1 minus 2. If it is from 2 to 1, it is 2 minus 1. Any doubt? With this, we conclude the article which was to find the line integral of electric field. The line integral of electric field, which is obviously equal to the work done. In the next article, we will continue afterwards. Till that time, take care of yourself. Keep revising this article. This is one of a very important article. And if you have any doubt, get back to me. Take care of yourself. Thank you very much. God bless you all.